Hello and welcome back. Alright, so the last video we took a look at our basic design of our tic-tac-toe game. So in this video I want to go ahead and talk through the setup of the project. If you remember back from our initial videos about this segment of the class, one of the goals was cross-platform development. And so in order to actually set us up for some success in this area, we need to talk about how we're going to structure our projects. Because we're going to have project files for Xcode, we're going to have project files for Visual Studio, and so we don't want to clutter, I guess, all of our source code structure with all these different build outputs and project files. So we're going to talk about how to structure that. We're also going to talk about source control. I'm going to be using a source control system to shuffle my files from my OS 10 to my Windows. You guys are free to use whatever you want to. I'm going to be talking about Git. Let me write that down for you. Git, G-I-T. It's a distributed source control system. So we'll be spending a little bit of time in this video just talking about what Git is, the basics of how it works. And then our next videos we'll actually go ahead and set up our projects. So let's talk about our source control. Sorry, not our source control, our source code layout. Okay, so we're going to have a basic root folder. And this is going to be called tic-tac-toe. I know. Very unobvious. So this is where it's going to house all of our files for this project. So inside here, I want to create a folder called source. I'm going to create a folder called documentation. And I'm going to create another folder called projects. So why am I doing this? Well, like I said, we're going to have multiple source files for our project. We're going to have multiple project files for our project, depending on what platform we're working on. So I want to keep everything nice and organized. So I want to put all my source code under a source folder. I'm just doing that for personal preference. You could put all your source files right in the root here. I'm doing it to help me clean up my organization, so I always know that my source files are in one location and I know exactly where that is. I do this pretty much for all of my projects. This also allows me to put like some README file in the base directory, or if I need some sort of shared files or like some scripts that I need to run in order to get project files generated, or a generic make system, for example, or a to-do list. I might put those kind of things in the root directory. And so I don't want to pollute my source code with those root type files. So under source, we're not going to really have any other folders here, so we'll just write CPP files, so we know what's going on here. CPP files and .h files. Okay. Our documentation folder. Both Xcode and Visual Studio can output documentation based on the source code that you have, and so this is where I'm going to store those files. I might put some more advanced documentation, like if I actually want to create a real help file for my game so that people understand how to play tic-tac-toe and how to use the program that we make. I might put that stuff in this folder too. So right now we're just going to have we'll just put help files. Okay. Now under my projects folder here, I'm going to want to create two separate folders. So what I'm going to do is I'm actually going to create a folder for every product that I'm working with. So I'm going to have a folder for Xcode. I'm going to have a folder for Visual Studio. And if we were going to use another build system, let's say we were going to use Eclipse as well, for maybe the Linux guys want to use Eclipse, I would create an Eclipse folder there as well. I'm not specifying the platform, like OS 10 or Windows. I'm not doing that because that's actually too broad for me. That doesn't really tell me anything about what's going to be underneath that that folder. For example, in OS 10, I could be using the Xcode project file, or I could be using standard a make file, and that doesn't really tell me what to expect in those folders. And I just don't find any value there. You're more than welcome to put them under a platform and then maybe even another directory if you want to have multiple builds depending on what you're running against, but it's totally up to you. But this is what I'm doing, and that's why I'm doing it. So we're going to have a Xcode folder, and we're going to have a Visual Studio. And like I said, maybe there's an Eclipse. Or you could have make. I'm not going to have these, but these are something that you might actually have. Okay, so this is what our basic structure is going to look like for our project system. So let's actually just write project system up here. And project system starts with a P. Project system layout. Okay, so let's get back over to Git. What is Git? Git is a source control system. So what does that mean? Source control system is basically a mechanism for storing revisions that you make to individual files. In the case of Git, Git's really about changes that you make to all of your source files. Basically what that means, let's say you had a program that you started out, it just says int main and return 0. And then you save a snapshot of that file. And that's like your basic or initial commit or your basic state for your file. So you basically have this. So we'll call this 1. This is our basic or our initial. And let's say you add a few more things to your code. So let's just say this just has main. Okay, so you add some more things to your code, and now you have main, and now you have the foo function. And you're pretty happy with that. You want to save that in your history. So we'll call this 2. And so this is like your add foo. So over here, we kind of got these descriptions that we have associated with these check-ins or these snapshots of the code that we care about. These descriptions actually tell us some information about what I did and what's in these versions of the file. So now we have like this history chain, and so this is really what source control is for. It allows you to track changes that you make to the files over time so that, if you mess up or you need to see what happened, or in a case of a larger group or a larger organization, you can figure out who did a certain change so that maybe there was a bug or you have a question about the design or a question about the implementation of why they did something a certain way. You'll have an owner that you can go talk to with that code. So let's say, we might have an owner. We'll just say owns D. That would be me. Owns D. So now you have this description. So let's just write that down here. Description and the author or contributor. Author, contributor, owner, committer. Those are kind of all the same term that refers to who made that change. All right, so that's really the basics of Git, just source control in general. That when you start talking about source control, you'll hear terms like distributed or server client, and really, for our purposes, those are all irrelevant. Like, it doesn't really matter. I'm using Git because I like some of the advantages that it has. I like that it has local commits. A lot of source control systems are essentially set up like this, where you have some computer off in, we'll call it the internet, or the buzzword, I guess, that everybody says is the cloud. This is really just online somewhere. And then you have your little computer over here. He's happy. He's making some code. We'll call this my computer. And then I'm connected to this server, and I pull down this code. And maybe you're over here. You're not so happy because you're having to take in my code. This is kind of the server client model. And this is typical of how a lot of things are set up. This is actually how I use Git a lot of the ways too. But the nice thing about Git is that it allows you to kind of keep a local history as well. So I can check in locally on my box to say I'm not connected to the internet, but I still want to keep track of all this history. I can make these check-ins locally on my machine, and then when I do get a chance to get connected, I can push all of this history. This is the nice thing. I can push this entire history up here, and then that allows me to see that history chain and let other people see that history chain that I did on my work, so I don't lose all of that, which is really nice. So that's basically why I choose Git. It also works on Windows and Linux and OS X, so it's pretty well supported across multiple platforms. And then the third reason I choose it, there's a pretty good website that allows you to host free open source projects. You can also pay to have private, what they call repositories. Repository is just the collection of your code for a specific project usually. And that website's called GitHub. But yeah, so the basic models for Git here, let's just talk about some of the instructions that you're going to be using. So like I said, we have our files, right? We start here. This is 1. This is 2. Well, in Git, in order to actually make a change or to let Git know about a change or a new file, you do git add, and then you do the file name. And then you do git commit, and then that checks in all of the files that you currently have staged. So this git add basically puts it into a list of files that are going to be or that can be committed into the Git history, essentially. And then so right here, this line then creates this kind of one snapshot that I can then refer to back. And so basically I'm going to be using 4 commands throughout most of these videos. It's going to be git add, git commit. And so let's say I have my Windows PC right here, and I have my OS X, and then I'm using GitHub as kind of my central. GitHub. So I need to put those files up here, and then I need to get those files over here. So the way I do that is I do a push command here, and over here I do a pull command. Now I could pull directly from here and push and pull directly from these two pieces. The reason I'm not doing that is sometimes I'm not at my house or I'm working on my laptop, and I don't have access to my desktop computer without setting up a bunch of stuff that I don't want to do on my main computer. So I want to use a central location that's outside of my home network. So that's why I'm using GitHub. And also it has some issue tracking and forums associated with your project, so that's pretty nice. Okay, so git push, I guess. So the command is git push, and then that pushes it up to a server that you specify. So it's like git push origin, and then this is just some server name. So git colon blah 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 somewhere, and then git pull. Same thing. You can associate a name with a location, that we don't have to type in the URL all the time. So those are really the 4 commands that we're going to be using for the most part. And I know that was kind of the, the quick 5-minute slam your head into the wall, introduction to Git. If you want to find out some more information on Git, I encourage you to head on over to git-scm.com. It has some great documentation. It also has the download links for Git. There's Windows, OS 10, and then source links for all of you Linux lovers that like to build your stuff. There's also other downloads that I think you can get binary drops for a lot of the Linux distributions as well. If it's not actually already installed on your system, which is pretty common as well. But so here you go. Basically, quick look at this. There's some quick starts here. Clone is the one command I didn't talk about. Clone basically just says, hey, I want to start a new repository based on a remote repository. So when we set it up, let's say I started my repository on OS 10 and I push it up to GitHub. So the very first thing we do, instead of doing a git pull, what you do is you do a git clone. And that initializes a local Git repository for you and pulls down all of the information from the server. And yeah, so the documentation links, just follow this guy right here. There's some nice short and sweet information. But, really gets a lot more, there's a lot more power in Git than what I'm showing you. But for our purposes and for the needs of most simple little projects, that's really basically it. Okay, so I've rambled on enough about Git. So in the next video, we're going to go ahead and create our OS 10 project, add that into Git, and get started with our cross-platform building. So with that, thanks.